Alright, so in these next couple of examples, we have like terms within our problem. So our first step where we can, and this is when we have variables that are on the same side of the equal sign. So notice that these ends are both on the left of the equal sign. So when we have that, we're going to combine like terms. And remember that I show my work in the videos the same way I want you to show your work. So my first step is going to be that I am going to add 13.6 plus 12. Or you can invert these two steps however you would like. But we're going to start with 13.6 plus 12. So that gives me 25.6 n equals 128. And so again, I did a combine like terms. I like to call that CLT. So if you hear me say we'll do a CLT, that's what I mean. Combine your like terms. From here, because I really dislike decimals, it's so much easier to work with whole numbers, I'm going to multiply both sides by 10. And I do that because there's only one decimal place. So I'm going to multiply by 10, in which I will get 256n equals 1,280. Your answer's going to be the same. You're probably going to use a calculator, but like I said, to me, it's nicer to look at non-decimal numbers, so our whole numbers. So in order to get that, that was a multiplication property of equality move that I made, and now I'm going to do a division property of equality and divide both sides by that 256. So when I take 1,280 and divide by 256, I get that n will equal 5. And so again, that was that division property of equality in order to get there. So if I'm not sure, then I plug it back in and I do 13.6 times 5 plus 12 times 5, and it should equal 128. So 13.6 times 5 is 68, and 12 times 5 is 60, and 68 plus 60 is 128. And so it works, and I know my answer is correct. So, and I had made that comment that we could either do the combine like terms or the multiplication property of equality. Either one of them could have gone first. I could have multiplied everything by 10 and then combined like terms. Instead, I combined like terms and then multiplied by 10. Your choice. Or you don't multiply by 10 at all. Again, your choice. Alright, our word problem. So, I rake leaves for 2 hours on Saturday, so I know Saturday is 2 hours, and 5 hours on Sunday, so Sunday is 5 hours. My neighbor pays, or your neighbor pays you, so a total of $63. How much do you earn per hour? So we want to know money per hour. That's what we don't know. So we're going to call that X. You could call it M, you could call it T. That's just going to be my variable. That's what I don't know. And so what I need to look at is, well, where would that go? And since this is per hour, it should probably go next to our hours, right? So we had 2 of those. On Saturday, I worked 2 hours, so that would be 2x. And on Sunday, I worked 5 hours. That and a lot of times means addition. Most of the time. And the fact that we have total. definitely means that we're doing an addition problem. So 2x plus 5x will equal 63. So that's how I figure out my equation. From there, we're going to do a combine like terms, and 2x plus 5x will equal 7x. So 7x will equal 63. And then in order to get x by itself, I'm going to do a division property of equality and divide both sides by 7 so that this becomes a 1x. So x will equal $9 per hour. And then if I'm not sure, then I can just double check and do 2 times 9 plus 5 times 9. That should equal 63. So 2 times 9 is 18. 5 times 9 is 45. So we should, again, we're working towards that 63. 8 and 5 is 13. 4, 1, and 1 is 6. So we get 63 equals 63, which means I did my math right. If I didn't get 63 equals 63, first I would double check that I did my math here correctly, and then I would just double check step by step, normally working backwards. Did I take 63 divided by 7 and get the correct answer? Yeah, okay, well, did I add things correctly? So normally if you work it backwards, you'll find your mistake. If not, you're always welcome to come talk to me. And then that is all for 2.1. Until our next video,